Have you ever wondered, why does lemon juice taste sour? Why can soap feel slippery? And how do scientists know whether a substance is acidic or alkaline? In this lesson, you'll learn everything you need for GCSE Chemistry. We'll cover acids, bases, alkalis, the pH scale, indicators, neutralization, and the reactions of acids. Let's get started. What is an acid? An acid is a substance that releases hydrogen ions, H+, when dissolved in water. The more hydrogen ions an acid produces, the stronger its acidic properties become. Characteristics of acids. Acids have several important properties. They taste sour, never taste chemicals in a laboratory. Their pH is less than 7. They turn blue litmus paper red. They react with metals to produce hydrogen gas. They react with carbonates to produce carbon dioxide. They conduct electricity when dissolved in water because they contain ions. There are two main types of acids you need to know: strong acids and weak acids. Strong acids completely ionize in water. That means almost every acid particle releases hydrogen ions. Examples include hydrochloric acid, nitric acid, sulfuric acid. Because they produce many hydrogen ions, their pH is very low. Weak acids only partially ionize in water. Only some of their particles release hydrogen ions. Examples include ethanoic acid, citric acid, carbonic acid. Weak acids still contain hydrogen ions, just in much smaller amounts than strong acids of the same concentration. What is a base? Now let's talk about bases. A base is a substance that neutralizes acids. Bases react with acids and remove hydrogen ions. Not every base dissolves in water. What is an alkali? An alkali is a base that dissolves in water. When an alkali dissolves, it releases hydroxide ions, OH-. Examples include sodium hydroxide, potassium hydroxide, calcium hydroxide. Remember this important GCSE fact. Every alkali is a base, but not every base is an alkali. Characteristics of bases and alkalis. Bases and alkalis have several common properties. Their pH is greater than 7. They turn red litmus paper blue. They neutralize acids. Alkalis produce hydroxide ions in water. Many alkalis feel slippery, although chemicals should never be touched directly. Now let's understand the pH scale. The pH scale measures how acidic or alkaline a solution is. It goes from 0 to 14. A pH of 7 is neutral. A pH less than 7 is acidic. A pH greater than 7 is alkaline. The lower the pH, the stronger the acid. The higher the pH, the stronger the alkali. For example, battery acid is close to pH 0. Lemon juice is around pH 2. Pure water has a pH of 7. Soap is around pH 9 or 10. Sodium hydroxide solution is close to pH 14. Scientists don't guess whether something is acidic or alkaline. They use indicators. Indicators change color depending on the pH. Types of indicators. First, litmus paper. Blue litmus turns red in acids. Red litmus turns blue in alkalis. Universal indicator. Red means a strong acid. Orange or yellow means a weak acid. Green means neutral. Blue means a weak alkali. Purple means a strong alkali. What happens when an acid and a base react together? This reaction is called neutralization. During neutralization, hydrogen ions from the acid combine with hydroxide ions from the alkali. They form water. At the same time, a salt is also produced. The general equation is acid plus base produces salt plus water. If the base is an alkali, the reaction is often written as acid plus alkali produces salt plus water. Example: hydrochloric acid plus sodium hydroxide produces sodium chloride and water. Acids react with different substances in different ways. Let's learn the 3 important GCSE reactions. Acid plus metal. When an acid reacts with a metal, it produces a salt and hydrogen gas. General equation. Acid plus metal produces salt plus hydrogen. Example. Hydrochloric acid plus magnesium produces magnesium chloride and hydrogen gas. The hydrogen gas can be identified with a squeaky pop when tested with a lit splint. Acid plus carbonate. When an acid reacts with a carbonate, 3 products are formed. General equation. Acid plus carbonate produces salt plus water plus carbon dioxide. Example. Hydrochloric acid plus calcium carbonate produces calcium chloride, water, and carbon dioxide. The carbon dioxide turns lime water milky. Acid plus metal oxide. Metal oxides are bases, so they react with acids during neutralization. General equation. Acid plus metal oxide produces salt plus water. Example. Sulfuric acid plus copper oxide produces copper sulfate and water. The name of the salt depends on the acid used. Hydrochloric acid forms chlorides. Sulfuric acid forms sulfates. Nitric acid forms nitrates. For example, hydrochloric acid plus sodium hydroxide forms sodium chloride. Nitric acid plus potassium hydroxide forms potassium nitrate. Sulfuric acid plus magnesium oxide forms magnesium sulfate. So let's quickly review everything. Acids release hydrogen ions, H+, in water. Bases neutralize acids. Alkalis are soluble bases that release hydroxide ions, OH-. Acids turn blue litmus paper red. Alkalis turn red litmus paper blue. A pH below 7 is acidic. A pH of 7 is neutral. A pH above 7 is alkaline. Acid plus metal produces salt plus hydrogen. Acid plus carbonate produces salt plus water plus carbon dioxide. Acid plus base produces salt plus water. Hydrochloric acid forms chlorides. Sulfuric acid forms sulfates. Nitric acid forms nitrates. Now you understand the complete GCSE topic of acids and bases. Thank you for watching. If you found this video helpful, please like, subscribe, and share it with your friends. Your support really helps the channel and allows me to create more chemistry lessons like this. If you have any questions, feel free to leave them in the comments below, and I'll do my best to help. Thanks again for watching, take care, and I'll see you in the next video. Goodbye.